This is a spiral galaxy, one of hundreds of billions of galaxies in our universe. It consists of over 100 billion gravitationally interacting stars, which form a complex rotating system. Let's look at the rotational velocities of the individual regions of the galaxy in more detail. Starting from the center of rotation of the galaxy, the graph representing the rotational velocity of the galaxy initially increases steeply with ever greater distance from the center of rotation. However, at a specific distance, the graph levels off and remains almost constant. Naively, it had been assumed that the rotational velocity would fall off according to Kepler's third law. However, Kepler's third law describes the orbital velocity of planets orbiting a single star. It was claimed that the discrepancy between the two graphs would cause the stars on the fringes of the galaxy to be catapulted away by the centrifugal force. Therefore, the existence of a dark matter was postulated that is supposed to prevent the galaxies from breaking apart. This dark matter is believed to comprise about 24% of the total energy of the universe. However, dark matter is a myth. Why? Let's look a bit closer at the planetary motion in our solar system. In 1618, Johannes Kepler described the orbital velocity of the planets orbiting the Sun with his third law of planetary motion. It is important to know that the Sun contains about 99.9% of the total mass of the solar system. As you can notice easily, Mercury, the closest planet to the Sun, has the highest orbital velocity of all planets. The other planets demonstrate increasingly lower orbital velocities the further they are away from the Sun. This results in a velocity curve that was naively applied to the rotational dynamics of galaxies. However, there is a huge problem. The orbital dynamics of planets orbiting a central star can in no way be compared to the complex rotational dynamics of a galaxy comprising hundreds of billions of stars. Before describing the rotational dynamics of a galaxy, let us first consider a spinning top. A spinning top is a rigid body. When looking at individual points on the surface of the spinning top, we notice that the rotational velocity of the different points increases the further away the marked points are from the center of rotation. Graphically, this corresponds to an increasing linear graph. In contrast to a planetary system in which 99.9% of the total mass of the system is concentrated in the central star, a galaxy consists of over 100 billion individual stars, forming a complex gravitationally interacting rotating system. Thus, the rotational dynamics of a galaxy is not at all comparable with the orbital dynamics of a planetary system. Close to the center of the galaxy, the rotational velocity of the galaxy behaves, due to the high star density, like a rotating rigid body, just like our spinning top. Beyond a certain distance, the star density decreases greatly. Therefore, the rotational characteristics of a galaxy are a combination of the rotational dynamics of a rotating rigid body and the orbital dynamics of planets. The actually observed rotational dynamics of galaxies guarantees their stable rotation. Dark matter is therefore a fairy tale, a mysterious chimera that is easily refutable through the application of physical laws. However, astronomers insist that the dark matter chimera makes up 24% of the total energy of the universe. Another 71.4% of the total energy of the universe is attributed to another elusive energy known as dark energy. According to current consensus, the observable, verifiable universe only makes up a pitiful 4.6% of the total energy content of the universe. Dark energy, which is cited as the supposed cause of the expansion of the universe, is likewise pure fantasy and a miserable attempt to make the cosmos an esoteric playground. Learn more about this topic in the book Einstein's Universe Without Big Bang and The Solution of Hawking's Paradox.